This is called an electromagnetic diver. So that diver is made up of a plastic tube with water inside. Can you see the water? And I'm going to insert something floating, and that is iron. And this one is aluminium, so I put it there like this. And I'm going to pass 6 volts DC, direct current, into this. And let's see how the magnetic field of this coil of wire affect the floating cork that carries aluminium, and the other one carries iron. Okay, can you press this now? What? You went in now. Huh? I go. Ah, then it came out again. I press again. Yeah, and then it came out again. Good. Now, the question is, what if I were to change the polarity? What do you think will happen? Will it jump out of the water? If I change polarity, what do you think will happen?
Nothing.
It should be the
Opposite?
how to have opposite like that?
Oh.
Huh? They jump up. Okay, never mind, you press and see. It's still the same. Huh?
Oh.
It's still the same, goes in. Let go. Yeah. Okay, that was aluminium, right? Now I put in brush. Let's see what happened to the brush. And you find that the brush, B, eh?
Yeah.
No. What happened to the brush? Let go. Right? The brush got sucked in. Oh, cannot. It's too heavy. The brush cannot float. Oh, it's too heavy. It's too heavy. Never mind. Alright. So if I were to change the polarity press, it'd still be the same. Iron will go in. And of course, if I put it higher, the magnetic field must be strong enough to pull it in. What happens if I were to use alternating current on this? If I were to use alternating current, I'll put it here. That means the current goes sometimes in this direction, sometimes in the other direction. Okay? And now you press. It still goes in. Alternating current still has a magnetic field. Okay? Actually, you can feel a little bit of vibration, but it's quite difficult to feel because the current changes. The current changes about 100 times in 1 second. Yeah, it's that fast because of the way it is generated. So, whether I change the polarity of the DC or I change the DC to AC, it will still attract the iron, right? Yeah, which means that the iron will assume, the iron lower at the point will assume an opposite poles to this section, the top section. That's why it gets sucked in. Like what we saw, the needle got sucked in by the solenoid just now. Okay? So, yeah.